Hello, YouTube. So, I've been nerding out again lately, and I figure I might as well share my nerddom with everyone else. What have I been nerding out about this time? It's just a question of physics and cosmology. No big deal. Just, everything. So, what's the issue? Well, physics is quite interesting in that there's a basic principle at work in our equations, one which tells us that physics should be consistent from every single vantage point. That is to say, there's no particular place that's held in more esteem than any other place. There's no privileged location or time. Where it's most commonly seen is when we say that the Earth itself isn't special. Now, I use those air quotes because the concept of special means something particular here. What we're saying is that physics will work just as well on the moon as it does here on Earth, so there's nothing special about the Earth that makes physics work here. Indeed, we would expect that fundamentally everything we could do on Earth could equally be done on the other side of the galaxy, or even in completely different galaxies, and physics should function the exact same way. And by and large, this is 100% accurate and the right way for us to consider physics. There's really only one glaring problem. See, the equations of physics often include time as a variable. For example, velocity is distance divided by time. And what's even more fun is when we consider acceleration, which is the change of velocity over time. Since velocity includes a component of time, and acceleration is the rate of the change of that velocity over time, then acceleration is written in units of time squared, not just time itself. The relevant point to bringing up acceleration is that it's actually possible to have negative acceleration. In the vernacular, we often call that deceleration, but in physics it shows up as a negative number. And technically, since velocity includes a spatial component, acceleration changes even if an object changes direction while maintaining a constant speed. To give an example of what that means, suppose you have a constant engine that propels an object at, say, 12 meters per second. When it goes from point A to point B, you say that the object has a velocity of 12 meters per second. But when it goes from point B to point A, you would say it has a velocity of negative 12 meters per second. Now, why do I bring that up? Because in physics, there's nothing stopping any of our equations from having a negative value, which would return the universe to a previous state. That is, if we were able to measure all the particles in the universe, freeze everything in place, flip the signs of all the equations and start it running again, then the universe would go backwards exactly like if we ran a movie backwards. There's nothing in the equations of physics that prohibits this. So why doesn't it happen in real life, so to speak? Why is it that time has a direction that only flows from the past to the future? There's nothing in physics stopping time from being a negative value and resetting things. So what is making that happen? The usual explanation for this is that we have entropy. Entropy is the amount of disorder in a system, and the laws of thermodynamics tell us that entropy is always increasing in a closed system. That is to say, in a closed system, disorder increases while order decreases. We can think of it this way. Here in my hands I have a book. It's a Bible, and this particular Bible has around 2,180 pages. But here's the thing. Those 2,180 pages are arranged in a specific order. There's only one order that is correct, but those 2,180 pages can be arranged in trillions of incorrect ways. If we were to take the pages out, shuffle them, and then put them together, we will almost certainly end up with an incorrect order of the pages, because there's only one possible way to get them all correct and billions and trillions of ways to get them wrong. This illustrates entropy because we start with a highly ordered system. These pages are all aligned in the correct order. If we remove the cover and sat the pages in a room and left them there for a year, the pages could not get more ordered than they began. Anything that disturbs the pages, such as a gust of wind under the door or a cat running through and jumping up to the desk where the pages are sitting, would increase the disorder. The order would decrease because the pages would begin to get mixed up, until finally at some point the pages would be completely random and you would have maximum disorder. Now here's the thing, when you have maximum disorder, if you randomize the pages more, you're not going to see the difference. So The only way to tell if something is getting more disordered is if there is some level of order to begin with. So the idea of entropy then is that the universe has an arrow of time that points in a specific direction because entropy increases through time. Things move from an ordered system to a disordered system. That's what gives time a direction, and that's why the future always comes after the past. If the present was completely disordered, there would be no arrow of time, because the past and the future would be equally as likely in the laws of physics, in those equations of physics. The ordered system is very, very rare, while disorder is very, very easy to have. And an ordered system won't spring about randomly. So that sounds like a good idea, a good explanation. It sounds like it solves our issues in physics and provides a good explanation for why time has a specific direction from past to future. There's only one slight problem. We exist today in a universe that has quite a bit of order. Again, that's why we can see time's arrow. If we didn't have the order here, we wouldn't have an increase in entropy to give us time's arrow. But how did we get into such a highly ordered universe today? Again, the amount of order in the universe is too much to have randomly come about. It can only be explained, as we just did, by stipulating that yesterday the universe was even more ordered than it is today, which is why today entropy has increased and time has flowed from yesterday to today. But think about that. If the odds that the universe today is as ordered as it is are so unlikely that we're able to perceive time's arrow by the increasing of entropy, then how can we assert that yesterday's universe, which is even more ordered than today's, and therefore even more unlikely to have just sprung about, is the explanation for today's universe? That is, if we're saying it would be miraculous for today's universe to spring into existence from randomness, with the amount of order that we have now, it's even less likely for it to have done so yesterday, and even less likely than the day before, and so on. And that brings us to a very real paradox. How is it that the universe exists with any order at all, when every day we move back in time requires us to have an even less likely universe than today's universe? Because it has to be even more ordered than our current universe in order to explain the current order in our universe, giving rise to time's arrow. Every step back in time becomes less probable, even if it's necessary in order to explain today's universe and the arrow of time. So there you go, the entropy paradox. Is there a good solution to it? At this point, who knows? But it's something to think about, and I hope you do. And as always, I hope you have a wonderful day. Peace out.